Hey everyone, and welcome back to more math lessons with Mr. Oldenborg. We're starting our whole unit on volume coming up, which is pretty important because the state pretty much gives you 30% of your test based on volume. And while the math isn't terrible, understanding everything about volume is what takes a little bit of practice. So let's talk about what we need to know. The first thing is, let's jump to this page because it's out of order. Let's talk about vocabulary, because just like reading, without vocabulary, you're not going to understand what you're being asked to do. So the first thing that we're going to talk about here is volume. Volume basically is the space an object takes up. It's 3 dimensions, okay? When you were in 3rd grade, you did a little thing called perimeter, right? And with perimeter, you would have to measure each side all the way around. Well, let's say 20. And it would be like feet, and you'd get 20 feet because you were measuring the length. It's an interesting letter I made. Then, 4th grade, you started with area. And the area of an object, you started doing length times width, and it would be in square units because you used 2 dimensions. It was length times width. We had a length, a width, 2 dimensions, 2 in the exponent, squared. Now, we're going to be talking about volume, which is the space something takes up. All right, it's not just a flat object anymore. Now we're talking about a 3-dimensional shape because we're going to have a length, a width, and a height. And volume is length times width times height. And if you notice, this bad boy has 1, 2, 3 dimensions. So whenever I write my answer, say these are in feet, it's going to be in cubic units because it's the 3rd dimension. All right, so cubic unit is volume of a cube measuring 1 unit on each edge. This is a unit cube. All right, a unit cube is 1 cube whose every side is 1 unit large, no matter what you're measuring. And that will be a cubic unit. Now, we try to fit a bunch of these into an object to see how many cubic units or cubic feet or cubic centimeters or cubic whatever are going to fit into these geometric figures, like a rectangular prism. A rectangular prism is a rectangle. Should get my little pointer out. It's a rectangle. You see, here's your rectangle, or here's your rectangle, right? But it's in 3 dimensions. It has a width and a height. So it's no longer just a rectangle. Just like a cube over here is not a square. A lot of times, students get this confused. They draw this and they say, there's a cube. It's not a cube. That's a square. It's 2 dimensions. It's got a length and a width. It needs a height to become a cube and be in 3 dimensions. All right? Some basic technology. The vocabulary. I'm using technology. Let's take a look at this. Gina decides that she has this art project. She builds a rectangular prism. She says that it's 3 cubes long, 4 wide, and 2 high, and they want to know the volume. Couple of things I want to talk to you about before we start. Trying to say, less Mr. Oldenborg. Here, I have a rectangle. Now, I have a rectangular prism. Shazam. You need to know what the length, the width, and the height are. You will always have a horizontal value, and that will be the length. You will always have a diagonal value, and that will be the width. And finally, you will always have a vertical value, and that will be the height. So, whenever you're figuring these out, you need to make sure that not only do you just have 3 numbers, so when we get to combining volumes, you're going to have to be separating stuff and figuring out what numbers go where. You will always need a horizontal, a vertical, and a diagonal. So we need to make sure that we label our diagram right. It says 3 cubes long. That's a length. 4 cubes wide. And 2 cubes high. So if I was labeling my unit, my rectangular prism, that's what it would look like. And if you look over here, you're going to see that they had already done that for us. 1, 2, 3 long, 1, 2, 3, 4 wide, 1, 2 high. All right? Length, oh, go away, come on. Length, width, height. Now with today's lesson, it's a little bit more basic than what we're going to be doing in the next lesson, where they're giving me the cubes. Another point that I want to make sure that you know is the fact that these cubes up here are not just in space. You have a whole layer underneath holding them up. So even though you see like the top of one cube here, there's really 2 cubes back there. One from this bottom layer and one that this top layer sits on. There is an empty space there because things just don't float. So they want us to multiply these numbers together. What does my multiplication sentence look like? It looks like that. Now, it does not matter which numbers I decide to multiply first, because the associative property of multiplication says no matter how you choose to multiply these numbers, you're going to get the same answer. So I like to look at what's going to be easy. Now, I could do 3 times 4 first and get 12 times 2, which is 24, and that's pretty basic. All right? Now, the other thing is it's not just 24. It's 24 cubic units. Without your units, you're going to be wrong. You have to label what you're talking about. If we were architects and we were doing things in feet and we decided to not put our units and somebody did inches, well, things just aren't going to turn out very well for you kids. You won't be an architect very long. The other thing is, if I had this problem and it looked like this, maybe I do 4 times 2 first. Oh, 3 times 8, that's a multiplication fact. You're still going to get 24 cubic units. No matter how you decide to do this, it's all going to work out beautifully. Ooh, my iPad's taking a second. So let's take a look at what we have. I might have to figure out the volume of this. They give me some models. I have to see what I have. Well, I know I'm going to need a length. I have 2 cubes as a length. I know I'm going to need a width. I have 2 cubes as a width. And I need a height. I have 2 cubes as a height. 2 times 2 times 2, which is really 2 cubed. Stick that there for fun. We're going to have 4 times 2. 8 cubic units. Mr. O, they didn't say inches, centimeters, whatever. How'd you know cubic units? Because they gave me cubic units there. These little guys are cubic units. So if they don't give you a measure, it's cubic units. Down here, same thing. I have 1, 2, 3, 4, 5, 6. By my width of 2 and my height of 1. 6 times 2 times 1. Well, I'm not going to multiply by 1 because I know it's just going to be the same thing. This is 12 cubic units. All right. And finally, the last page. 2, 4, 6 across, which is a length. Horizontal. Keywords. Use and listen to them, please. 2 for my width. It's the diagonal line. And my height, my vertical line. Hey, I changed that to blue. That's not fair. There we go. Computers. 3 cubic units high. 6 times 2 times 3. I'm going to make it 6 times 6 because that equals 36 cubic units. Number 12, we're going to have 3 on the horizontal line, which is my length. We're going to have 4 diagonal, which means that's my width. I should have put these in too. And my height, my vertical line, is 2. How do I want to do this one? Let's do 4 times 2 is 8. 3 times 8, 24 cubic units. Now, 13, I couldn't wait to get to. I wanted to use this line just to get to this problem. Boys and girls, that is an irregular shaped figure, isn't it? We don't have a rectangular prism. We don't have a cube. We have two things. So this is going to talk about what's going to happen later on in the future. Let's call it foreshadowing. Yeah, bring an ELA in. First thing I'm going to do is I'm going to cut this into two regular shapes. Now I'm going to have two separate problems, okay? In the real world, you could just count this stuff, but I want to show you what's going to happen later on because you're going to need this. So I'm going to have rectangular prism A and rectangular prism B. So again, just like I said before, I'm going to need a length, a width, and a height. So on A, I have 1, 2, 3 across. I'm going to label A, 3 times my width, which is going to go 2 back. How do I know 2 back? Because here is my diagonal line. 2 back. And my height is just 1 up. So A is 6 cubic units. Now I'm going to move on to B. By the way, this is called combining volumes because we're literally combining two different volumes. My length now is 2. My height, oh, why are you doing it out of order? It's already here. Pinkish, magenta, purple? I don't know. Is 4. Even though it touches down here, let me grab my pointer. Even though it's touching right here, that's totally okay because it's part of this figure. All right? And once again, like we said, it doesn't matter where you multiply. And then my width is 2. So I'm going to get 8 times 2, which is 16 cubic units. Now, I'm not finished. I have two different units. I have a 6 and a 16. When we combine things, we add them. So 6 plus 16, good old 22 cubic units. All right? That is called combining volumes. We separated an irregular shape into two regular shapes, found the volume of both, and mashed them together. You're welcome. This has been a lot of fun. Talk to you all later.